All right, so today we're going to be talking about central and inscribed angles. I'm hoping by the end of this lesson you're going to be able to solve for the measure of the central or the inscribed angle and their intercepted arc. So what is a central angle? A central angle is that angle whose vertex is located at the center of the circle, hence central angle. So here we have our center point, and I'm going to label that B. I'm going to label this point A and C. So we have angle ABC, which is our central angle. Now the thing we have to know about central angles is that central angles are equal to the intercepted arc. Okay, so when we find that central central angle measure, that's the same thing as the intercepted arc measure. So let's look at an example. Here we have angle that is 122 degrees, and we want to know its intercepted arc measure. It's just going to be 122 degrees, because remember, our property is telling us that the central angle is equal to the intercepted arc. Now on our second example here, they give us lots of numbers, but they're really only looking for the measure of this central angle here, which is across from this arc, which we're told is 140 degrees. So this central angle will be 140 degrees. Now, I'm going to take this a step further and say, what if we were looking for this piece? Now, we don't know anything about this piece, so we can't use this rule directly, but we do know that 65 is the arc measure here, so the central angle will be 65. And we also know that there's 360 degrees in a circle. So we're going to set 360 equal to 140 plus 74 plus 65 plus x. So when we add up this right side, we're going to get 360 equals 279 plus x. And then we subtract 279 from both sides, and we get our x to equal 81. Okay, that's an above and beyond kind of problem. On this problem, we have now x's involved. Okay, we're going to do the same thing though. We have a central angle given to us, that's 10x plus 5. They give us the value of the intercepted arc as 85, and we're just going to solve for x. So subtract 5 from both sides, we get 10x equals 80. Divide by 10 on both sides, so x will equal 8. Here it was only asking us to solve for x. Okay, that's all we had to do. Now this problem I would like you to try on your own, so go ahead and pause the video here, work through what you can, and then you can come back and check. Again, reminder, if you have any questions, please feel free to write them on the side of your paper and let me know in class when we're practicing. Right, so here once you solved, you should have gotten x to equal 1. Again, if you've got anything wrong, please pause the video here, go back and check and find your mistake. The next thing we're talking about today are those inscribed angles. Okay, so inscribed angles are angles whose vertex are located on the edge of the circle. Okay, so that's anywhere around the circumference. Okay, there's a point anywhere on the outside of the circumference making that angle. The rule here is going to be 2 times your inscribed angle equals your intercepted arc. Okay, so let's see how this will work with a few examples. Okay, so first I'm going to trace what I know. Okay, so I have this intercepted arc here, and I need to find the angle that is across from it. So I'm just going to connect my endpoints of my arc and see that I have a nice inscribed angle there. So again, the formula for this is 2 times my inscribed angle is equal to my intercepted arc. So I have 2 times my x that I don't know, okay, equaling 66. I'm going to divide both sides by 2, and I'll get my x value to be 33, which is indeed the measure of my inscribed angle. Okay, again, example number 2, I'm going to do the same thing. I'm going to trace my arc, okay, and I'm going to trace from the endpoints to an angle. Okay, so I know that my inscribed angle is 50, okay, and I have to multiply that by 2 to get my intercepted arc, which is what I'm looking for. So I'll have 100 equaling my intercepted arc. Remember to put your degree symbols. Okay. So if you have any questions, pause the video, go back, watch it a few more times. If not, we're moving on. Now here they're asking us to solve for x. I'm going to do exactly the same thing as when I was plugging in. I'm going to trace my arc. Okay. Then I'm going to trace the angle created from my arc. And I'm going to set up my problem. I have 2 times my inscribed angle, which here is 4x plus 14, equaling my intercepted arc of 108. Okay, don't forget that we have to distribute this 2 out in front. So we're going to have 8x plus 28 equals 108. I'm going to subtract my 28 from both sides. So I'm going to have 8x equals let's see, 70. Oops, 80. And I'm going to divide by 8. And I'm going to get x to equal 10. Okay. Now another way to have solved that problem would have been not to distribute the 2, but to divide by the 2 at the beginning. So I would have had 4x plus 14 equaling 54. Then I would have subtracted 14. Would have gotten 4x equals 40 and divided by 4. So our x equaled 10. Both options are perfectly wonderful. Okay, they give us the same answer, they're just different ways of thinking. For this next example, I would like you to try it on your own. So go ahead and pause the video and give it a shot. Okay, hopefully you noticed on this one that you were given your inscribed angle, so you just had to multiply that value by 2 and set it equal to your intercepted arc. So you should have gotten your x value to equal 14. Please go back and double check that you've done everything right. If you have questions, I will see you in class. Feel free to ask them.